Okay, this is the second case of partial fraction decomposition. It's the same as the other ones, regardless if they are special case, but the first step remains the same, and that is to write it as a sum of smaller fractions. Now, in this case, it's going to change a little bit than what you've seen before, in that the special case here happens because of this x plus 1 squared. And the only thing that happens is you need to sort of break it down as follows. So as you see now, the middle term, which is under the b, that's x plus 1 squared, and is exactly what you have under the denominator on the left-hand side. And then the next one is c, and under that we have x plus 1. So if it was cubed, it'd be BCD, starting with cubed, and then x plus 1 squared, and then x plus 1. And that's how this type of problem works. Now, the following step still remains the same, and that is to figure out the GCF. Okay, and the GCF, if you haven't already figured out the trick, is literally just the denominator on the left-hand side. And that usually works. And what you want to do now is multiply across. So, doing this visually, we have that for this left term over here, this whole GCF will cancel out with this denominator because it's exactly the same, so you're left with the top. And here, going to the right, the first term, x plus 2 is going to cancel out with x plus 2, and I'm going to be left with this here. And note that the numerator always drops, right? So that's x plus 1 squared plus, again, the numerator always drops. Then you could just say, hey, x plus 1 squared here cancels out with this one, and I'm left with x plus 2. Okay? And the last one, plus c. And if you notice, this you have to be a little careful. This is only 1x plus 1, and here we have 2x plus 1s. So this one will cancel out with 1, leaving you with x plus 2 times x plus 1. And we're done with the whole distributing the GCF. Now, at this point, it's pretty much the same as the other ones we've done before. Now, in this particular case, we do not have to do a system of equations. The reason being is because all these terms are separated, and that's how we want. In the other case, we had bx plus c, and in that case, bx plus c is not separated, so this requires you to sort of build the system of equations. So in this case, we're going to go straight, direct approach, and you choose let x equal a number. And in this case, your best options is either the -1 to cancel out a, or -2 to cancel out b. So for this particular case, we're going to go ahead and start by doing -1. And I'm going to give you a trick, and I hope that it helps. But feel free to plug in -1 to all the x's. But I highly advise against that, only so that you can save time. So for sure, always plug it into the left side. Okay. All right, and that's good. And on the right, I'm going to go ahead and plug it in to what it cancels, but I'm not going to do the math here, right? So -1 plus 1 is 0. All that term is going to go to 0. So really, you could put a times 0, or I prefer you just put 0 and acknowledge the whole thing is going to become 0. Now, for the b term, the middle term, that doesn't become 0, so I will write it. And then the last one, if you plugged in -1 in here, this whole thing, this becomes 0, multiplies to this, that all becomes 0. So I'm not going to go through all that, right? You can go ahead and do that, and you'll have the same outcome as me. You'll just have a little bit more work. So here we go. Simplifying this, -1 squared is 1 times -4, and then this is going to be plus 6. That puts us at 2 minus 5, that's -3. So here's -3 equals, and on the right-hand side, this here becomes 1. 2 is bigger, so it becomes b, and we're done, right? So we located b. So again, ultimately, your objective is to get your a, b, and c so that you can plug them in on top, and then you're done. So we're done with 1. We need a and c. My advice is to cancel out b next. So that forces you to let x equal -2. So let x equal -2 and proceed, right? Always on the left-hand side, okay? Squared minus 6 times -2, minus 5. And then it's not canceling out a, so I got to be careful with that, right? I want to make sure that that's plugged in. However, the middle term does get canceled out because when we plug it in -2 here, that becomes 0. And if we plug it in here, that becomes 0. Therefore, this whole thing becomes 0. So I'm going to put a plus 0 plus 0, okay, for the last term. And we do the math one more time. So -2 squared is 4 times -4 is -16. You can always do this just so that you don't have to carry that stuff in your head. That's 12 minus 5. So -16 plus 12 is -4 minus 5 is -9. And then on the right-hand side, we do have -2 plus 1 is -1, but it's being squared, so it's positive. So that means it's just a. Okay. Now the last one is going to be a little bit lengthy because if you notice, there is nothing you could plug in to cancel out A and B and just leave C. If you cancel out A and B, you're always going to cancel out C because C has both of these factors. So with that being said, plug in the easiest number. And to me, plugging in the easiest number means usually 99.9% of the time 0. Okay, so same thing. Now, in this case, I was about to compute, but if you notice, if you plug in 0 here, that's 0. If you plug in 0 here, this whole term is 0. So I'm really just left with -5. Again, you could do the work by yourself, but I'm going to put 0 minus 5 because that on the left becomes 0 except for the 5. And then none of this cancels out, so you have to be careful here. Plus 1 squared. You see, I put 0 plus 1 squared. I advise against that. I would just put 1, right? There's no need to write 0 plus 1. You could do that in your head. So the next one, I'm going to put b times actually just 2, 0 plus 2, right? Plus c times 0 plus 2 is 2, plus times 0 plus 1 is 1, right? So that really makes the math much easier. So just be careful. So 0 plus 1 is 1 squared, right? So that just becomes a plus 2b plus 2c. Now this is where a and b come back into play, and that's where you plug this a and this b into this b and this a, right? And that's going to help you solve for c. So a is -9 plus 2 times -3. Whoa. -3 plus 2c. That's what we're solving for, right? We don't have a c at the moment. So then right here we have, let me continue here to the left. -5 equals -9 minus 6, because 2 times -3 is -6. That's -15 plus 2c. So if I add the 15 to both sides, that's 10 equals 2c, right? So then that means c is equal to 5. So there we have all three terms. All you got to do is take your 5, your -9, and your -3 and plug it in here. So I'm going to go right ahead and do that. So my A was -9, okay, plus 2. B was -3, so plus -3 up here. Then x plus 1 squared plus 5 x plus 1. And we're done. That is your answer there. Nothing crazy. So now you know how to do this partial fraction decomposition, the second case. It happens to be a little bit lengthier, but it is actually easier than creating system of equations, in my opinion, right? So be careful with the two cases.